Hi, in this video we will learn how to solve exponential or logarithmic equations which have exponential terms or logarithmic terms. The the key point I should say of solving these equations that at some point we have to use the inverse function property, for exponential and log. So if you have b to the power something, that something is any expression, if you want to get rid of that exponential term, you have to take log of that term. So that will kill the exponential part and will be just box. And the other way around is also true. B to the power log of box base b is equal to box. This is the key point, meaning that wherever you have an equation which has exponential or log term in it, you try to make it put all of the term one side in the term of one log or one exponential, and then use these properties to get rid of that exponential term or logarithmic term. Let me show you through some examples this thing, and then I will write down the general idea of what to do. So paste. Okay, I have prepared these examples and then. Okay, so for example, let's start with the first one. 2 to the power 2x plus 1 is equal to 8. What we have, one side is an exponential expression, 2 to the power something. The right-hand side is a number. This is the best thing we can have for exponential equations. In this case, we want to get rid of that 2 to the power, the exponential. So you have to find log of the same base of both sides. So this will be log 2 of 2 to the power 2x plus 1 equals to log 8 base 2. Then left hand side, we'll use the property log 2 of b to the power something. It will come out as that something equals log of 8 base 2. Well, we know it is 3, it's just a number. Now you see this is a regular just algebraic equation. You can solve it. So isolate x and then divide both sides by 2, which gives us 2 over 2, which is 1. So that's, as I said, the key point is when you get to this point that you get rid of the exponential by that property. Here we have again one side is e to the power something exponential. The other side is 3 to the just a constant. This is the best thing. So we have to find log base e of both sides. Log base e is ln. So you find ln of e to the power minus x plus 2 and ln of 3. While the the left hand side is log e base e of e to the power something, so it will give us minus x plus 2. Right hand side, I don't know what is log of 3, but that's a number. Yes, at the end it will come out just, well, log 3 is a nice number. One can compute, well, calculator can do that one, but we will just keep it as constant, as if it is 1 or 5 or 10. And then isolate x. Here will be x equals to 2 minus ln 3. And that's the answer we are looking for, the solution. Well, when you look at this, the third example, you will notice that, okay, e to the power x, there are e to the power x's in both sides. In these cases, you have to first try to turn it into the easy cases as we had in example 1, 2, meaning that bring all the exponential terms one side with one base. That means that in this case, I can multiply both sides by e to the power x squared. So we get ex e to the power x squared equals to 1. Yeah. Well, use the properties of exponential. E to the power something times e to the power x squared. You can add the exponents. Now it is of the form that one side is exponential, the other side is number. Now you can use the inverse function property, find log of the same base. Here means ln of both sides. So ln of e to the power x plus x squared equals to ln of 1. And the inverse function property says that ln of e to the power something is that something. And ln of 1, log every base, in every base, when applied on 1, you get 0. Well, this is, now we have no exponential term. This is quadratic. Indeed, we can solve this by factoring out x. Then we have either x is 0 or x is negative 1. We have two solutions for this. Well, how about this this other one? Again, there are exponential terms spread out everywhere. Put them together. Bring all of them one side as much as you can. So this is e5x plus 1 times 25x equals to 2. When you want to put one side, all the exponential terms one side, you have to try to make it one big exponential with this one base. Here I have 5, I have 25, two bases. I have to make it one base. And this can be done by seeing that 5 to the power 2 is 25, yes? And now 25 to the power x is the same thing as 5 to the power 2 to the power x. Exponential of exponent of exponential is product of the exponent. So this is 5 to the power 2x equals to 2. Oh, sorry, this is not x. This is just 5 here. Yeah. Now that we have the same base, you multiply, you add the exponents. And now this is the case we like. One side is one exponential term. The other side is a constant. So then to get rid of the exponential term, we find the log same base of both sides. So log of 5, well, that is 3x plus 1 base 5 and log 2 base 5. Okay, so this gives us 3x plus 1, the inverse property. And well, log of 2 base 5, we don't know what is that. But that's a constant. Just keep it like that. That makes sense. It is as good as writing 2 there or 5 there. It's just a number, yes? It doesn't have any unknown in it. So that's the key point here. So then isolate it, log of 2 base 5 minus 1, and then, well, divide that 3 to the other side and get the final result. Well, this is the trick we will get. Bring everything one side, make one exponential term, use the inverse property, and then turn it into the regular equation or algebraic equation and try to solve that equation. Well, the same steps can be used to solve logarithmic equations. I have prepared some examples also here for you. So in the exponential cases, logarithmic cases, well, the important one is that, so if you have something base b, log of something base b, to get rid of that, you put it as the exponent of b. So it will give us box back. The only thing here is that you have to be careful. Box always needs to be positive thing, which is regularly at the logarithmic case equations. we have to check at the end that the solution we have, the expressions, the log expressions are defined at that solution. Okay, let me start with this one. Well, as before, we want to make one side one expression of log, the other side, well, numbers. Very nice. Now, you see there is a log base 3. To get rid of log base 3, you can put both sides as the exponent of 3. So it will be 3 to the power log x base 3 equals to 3 to the power negative 2. And well, use the inverse function property. This will give us x. This is 3 to the power negative 2, which is same thing as 1 over 9. Same thing goes here. We have ln. Well, this is very good. One side is ln, which is log base e. The other side is just constant. When you have this case, well, right away, what you do, you put both sides as the exponent of e. So it will be e to the power ln 2x minus 1 equals to e to the power 1. E to the power ln of something, this is the same thing, but base e. This will give us 2x minus 1 is equal to e. Solve that. This will give us e plus 1 over 2. How about this last example? Well, let me just first put this 10 here. This is log of x. Well, we have logarithmic equation, but there are several logs. So put all logs together means that bring all logs one side, and when you have them all one side and numbers to the other side, let's just do that. Then what you can do is that use the logarithmic laws of logarithmics and try to simplify it and make it one log. So this will be log base 10 of, well, log, sums of logs turn into log of products. Now we have one side all log, which is log of x squared minus 2. The other side is number. When you get to that point, put both sides on the exponent of the same base. 10 to the power log x squared minus 2 base 10 equals to 10 to the power 1. And this gives b to the power log something base 10 is just that something is equal to 10. Oh, there is an x here. I'm forgetting. Sorry, it's an x here. Well, the key point is that now we are down to the case that we have an expression which is algebraic expression, and in this case it's quadratic, and we can, well, use quadratic formula to solve this. So this will have two solutions. X equals to 2 plus minus 4 plus 4d over 2a. Well, let me separate these things. Plus, there will be a plus version, there will be a minus version. So this is plus version, there is a minus version also here. So let me just write root 44 divided by 2. Actually, we can simplify this guy. 44 is root 4 times root 11. But root 4 is 2, we can factor out. This is 1 minus root 11. This is 1 plus root 11. As you can see, this is a negative number. While solving logarithmic equations, you have to at the end check that the solutions you found satisfy what is in the domain of the logarithmic expression. Here you see this is a negative number, And the expression we had at the beginning, go back to we have log of x base 10. Well, x cannot be negative number, so this fails to be a solution. How about the other one? So 1 plus root 11. Root 11 is a little bit bigger than 3, so it is a number bigger than 4. It is positive, so it will satisfy this one. It is defined on this one. For this one, a number bigger than 4 minus 2, it is a positive number, so it will satisfy. Well, it is defined. That expression is defined for this value. So the only solution, although we had 2 solutions at the end, only one of them is acceptable. It's 1 plus root 11.